Okay, so we've been solving quadratics. If it's a quadratic, that means it has an x squared in the equation. First we did it by factoring, by setting it equal to 0. Then we did it by square roots, getting the x squared alone. Today we're going to learn to do it by completing the square, which means we have to make perfect square trinomials. Okay, so we're going to talk about first about just what completing the square is. So if you have x squared plus bx, you can split the b in half. And then square it. Split the b in half and square it. So we've got several examples where we're going to complete the square and make a perfect square trinomial. Okay, so if we look at our first example, I've got x squared plus 12x plus something. So the 12x, the 12 is my b. So I'm going to split that in half. And what do I get? 6. And then I'm going to take it and square it. And so it equals 36. So to make that a perfect square trinomial, half of 12 is 6. I square it, I get 36. So x squared plus 12x plus 36 is perfect square, which means if I wanted to factor it, it would just be x plus 6 in parentheses squared. Okay, so do you guys see how those are related to each other too? Okay. Do another example. This one has a fraction. It's a positive 6 because this is a plus sign right there. It depends on that sign between the a and the b terms, whether it's positive or negative. Okay. So like for instance, if we look at example b here, now my b is a negative 5. So I'm going to take negative 5 and cut it in half. So that becomes negative 5 over 2, right? And then I square it. So what's negative 5 times negative 5? 25. And 2 times 2 is 4. So it would be 25 over 4. And again, if I was factoring it, because we are eventually going to have to factor these, it would just be x minus 5 halves, the quantity squared. So again, it's negative 5 halves matches that negative 5 halves there. Okay? Any questions so far? All right. All right, so C, I've got 8x plus x squared plus 16. So is this one written in the right order? No. So it's a good idea to go ahead and rearrange it so you don't get mixed up. So x squared plus 8x plus, what's half of 8? 4, and then I square it. So what is 4 squared? 16. So 16 would go in the blank there. And then for this one, why don't you guys give that one a try on your whiteboards? The 4 squared was where the 16 came from, right here. Okay, so when I take half of the 7, what do I get? Okay, it's okay to leave it as an improper fraction. It's probably going to be easier if you leave it as an improper fraction. So we get negative 7 over 2. If I square that, you should have gotten 49 over 4. And then when you factor it, it is x minus 7 halves squared if you choose to factor it, which in these problems we don't have to, but we will in the next problem. So, okay, any questions there? All right, how about a nice easy one? Do E on your whiteboards. half of 16? 64. Okay, so yeah, half of 16 is 8. 8 times 8 is 64. All right, let's do F on your whiteboard. Okay, so half of 15 was 15 over 2, and then you square it. You should have gotten 225 over 4. All right, this is for your notes now. This time I'm missing the middle term. So I'm going to work backwards. Because if I take the square root of 121, that should be half of what I want for b, right? So what is the square root of 11? But then I have to do it times 2, because when we squared it, we cut it in half. So we're just working backwards, okay? So if we look at example H, that one's just a little bit trickier because of the fraction, but still we're going to do essentially the same thing. So what is the square root of 25? And the square root of 16 is 4. But I have to multiply that times 2. So we can make it 2 over 1. And then that reduces. And so it equals 5 halves. So 5 halves is what would belong in the blank there. Okay? Questions? Alrighty, let's do that one on your whiteboards then. Okay, so the square root of 81 was what? 9. And then you have to multiply it times 2, so 18. Alright, here's one with a fraction for you. Alright, what's the square root of 49?
7.
And the square root of 4? 2. But then you have to multiply it by 2. So you should have gotten 7. Okay, so that's just the first step in actually solving that way. So we're going to solve equations now using the completing the square. So the first thing you want to do is you want to make sure that it is in this form, x squared plus bx equals c, and that there's nothing in front of the x squared, that a is just a positive 1. A is just a positive 1. So we have x squared plus bx plus c. And we're going to do the example x squared plus 16x equals negative 15. Alright, so the first thing I'm going to do is I'm going to complete the square on the left side. So I've got x squared plus 16x, and I'm going to add something to it to complete the square. And then whatever I add on one side, I have to add to the other side. So what is half of 16? 8. And then when I square it, what's 8 times 8? 64. So I'm going to add 64 to both sides. Then I'm going to factor it. So this becomes x plus 8 squared, and then 64 minus 15 comes out to 49. Then I take the square root of both sides, and so I get x plus 8 is equal to plus or minus 7. Okay, is my x alone yet? No, so I'm not done with the problem. And don't forget that you are going to have a positive and a negative square root. So I actually have two equations here. I actually have x plus 8 is equal to a positive 7, or x plus 8 is equal to a negative 7. So then I subtract 8 from both sides, on both of them. I get x equals negative 1, or x equals negative 15. And if you want, you can still write them in the solution set if you prefer Just do not put them in parentheses, okay? Remember, that way is the solution set. Okay, questions? All right, let's do some more examples. Okay, this one is for your notes. All right, so we've got x squared minus 4x minus 6 equals 0. Is this the fashion or the form that it needs to be in for me to complete the square? What did I tell you guys it had to be? You have to do x squared plus bx equals c. So you want to get the number by itself over on the right side. So what am I going to do that? I'm going to add the 6, yeah. So now I've got x squared minus 4x, and I'm going to leave myself a little space, and that equals 6 plus whatever it takes to complete the square. So what's half of negative 4? Negative 2, and then I square it, and I get a positive 4. So I'm going to add 4 to both sides. So now I have x minus 2 squared equals 10. And I take the square root of both sides. Is 10 a perfect square? No. So I just leave it under the radical. So I get x minus 2 is equal to plus or minus the square root of 10. Am I done? Is the x alone yet? No, I still need to add the 2 onto both sides. And so that means that x is equal to 2 plus or minus the square root of 10. Okay? And if it was given to you as a solution set, again, that's actually two numbers. That's 2 plus the square root of 10 and 2 minus the square root of 10. Okay? So just understand that on a multiple choice test, the answer might be written 2 plus or minus root 10, but it also might be written with the brackets and as two separate numbers. So you have to understand that those are the same thing. All right, so on your whiteboards, I want you guys to give one a try. Okay, so you guys should have added 1 to both sides, and then when you factor it, it's x minus 1, the quantity squared. So if you take the square root, we get x minus 1 equals plus or minus root 2. And so x equals 1 plus or minus root 2. Okay, one more here I want to show you before we run out of time. Here I've got 8x squared minus 8x plus 25 equals 0. So if I subtract the 25, I get negative 25 on this side. What's half of negative 8? Negative 4. And negative 4 times negative 4 is a positive 16. So now when I factor the left, I get x minus 4 squared equals negative 9. Can I take the square root of a negative? No, I can't. So this one ends up being no solution. Now, you couldn't say that as soon as you subtracted the 25, because when you completed the square, you might have gotten a bigger number to end up with a positive. So you need to go all the way through completing the square before you decide if it's no solution or not. Okay? All right, and that's all I have for you today.